Hello everyone, this video is an introduction to vectors and scalars. It's a physics video, and first I'm going to start by telling you what a scalar is. A scalar is simply something in physics that tells you the magnitude. So for instance, a magnitude is simply a number. If you were to say that you're running at, I don't know, 5 miles per hour, that number is called the magnitude. Okay, so let me write it here. Five miles per hour. This is an example of a magnitude. Okay, this is a scalar because scalars tell you the magnitude. If we're referring to a vector, we need to know the magnitude and we need to know the direction. So if we're talking about a vector, then I would say 5 miles per hour going north. That's an example of a vector. In real life, a lot of people use the word speed and they use the word velocity and they interchange it because they think it's the same thing, but in physics, speed and velocity are actually two things. You see, 5 miles per hour is an example of what we call in physics the speed of an object. Speed is a scalar. Scalars, you only care about the magnitude, meaning the number, only the number. But on the other hand, velocity deals with the speed and the direction. So that's the velocity. Alright, so now that we covered that, let's talk about how scalars and how vectors are described. Well, first of all, a vector, say we're talking about vector A, this with a little arrow at the top. So this, whenever you see this, you know you're talking about a vector. A scalar, on the other hand, you have the same exact thing, but a scalar is put in absolute value. So this represents a scalar. Alright, so now that we have an understanding of more or less what a scalar is and what a vector is, and we know that speed is an example of a scalar, and we know that velocity is an example of a vector, I'm going to give you some more examples. You've probably heard of distance, and you've probably heard of another concept. Well, this one is fairly new because this is a concept used in physics. It's called displacement. They kind of mean the same thing, but you're going to see that they're actually a little bit different. Distance is actually a scalar quantity because you only care about how much you're traveling in total, whereas displacement is a vector quantity. You care about the direction. I'm going to provide you with an example now so you can see what I mean. Let's say this dot right here is going to represent your house. So this is home. And then you're going to travel this way 10 meters. You're going to travel going up for 5 meters. You're going to travel this way for 10 meters. And finally, you're going to travel down. Oops. You're going to travel down for 15 meters. And this is your ending spot. This is the school. So you're trying to go from your house to the school. Now, if we're talking about the distance, what you need to do is you need to say, okay, I'm starting at this point and I'm walking 10 meters this way, 5 meters this way, 10 this way, and 15. So what is the distance? The distance is everything put together. So it would be 10 plus 5 plus 10 plus 15. That would be the total distance. Displacement, on the other hand, is the shortest distance between 2 points. So, for example, displacement would be if this is where you're starting and this is where you're ending. What is the shortest distance between those 2 points? And the shortest distance is this right here. It's actually a line. The shortest distance between 2 points is a line. So let's go one more time so you can have the idea. Distance means you have to add everything, meaning 10 plus 5 plus 10 plus 15. That's the distance, whereas displacement is just this distance right here. It's the distance from the start to the end. Because what's going on is that since displacement is a vector quantity, you have to take in account the x directions and the y directions. We'll talk about that later on when we deal with adding vectors. Okay, so now that we talked about that, let's get into what a vector looks like. In physics, a vector is represented by an arrow. So this arrow is supposed to represent a vector. Let's call this vector A. And this arrow over here, let's call it vector B. Okay, so we have two vectors here. Let's say that this is a car, and here we have another car. If I were to ask you which car is going faster, is it car A or is it car B? Well, the length of the arrow tells you the magnitude. And remember, magnitude is how much you're traveling. So which car is going faster? This car, car A, is actually going faster because the arrow is longer. So the speed here is greater than the speed here. They both have the same direction. They both seem to be traveling this direction over here. So they both have the same direction, but definitely arrow A is bigger than arrow B. Okay, the last thing that I'm going to show you is how to an easy demonstration of how to add vectors. So let's say we have a vector this way. This vector is 5 meters, and we have a vector, another one going this way, and this one's also 5 meters. My drawing is not very good, but assuming they both have the same direction, the new vector is going to be 10, because if they're both going in the positive x direction, you add them. Now if I had this, a vector going this way, plus a vector going in the opposite direction, we have to use the negative symbol. Negative means it's going in the opposite direction. And these are like integers. Vectors are like integers in math where you can add them. So 5 plus minus 5, 0. You don't have any vector here. Okay, let's do one in the y direction. Let's say we have a vector, oops, that's not so good. Let's say we have a vector going up 5, and we have another vector going up 2. These vectors are going in the same direction, which means in the same positive y direction, so you get to add them, and it's going to be 7. So this vector is 7, and the last example that I'm going to give you, let's say we have a vector going 5 up in the y direction, and we have a vector going 2 down. Because it's going down, I'm going to represent that with a negative, because I like to say that up is positive and down is negative. So this is going to be 5 minus 2 is 3 going up, so plus 3. And in the next video, I'm going to show you more examples on vectors and how to add them, and more examples on this.